Hi, thank you everybody for coming to Halvard Buhaug's talk today on does the political context matter for disaster impacts. I have known Halvard only for a short time personally in terms of interacting with him, connecting with him around some work we're doing on a special feature which he and a colleague of his, XL, initiated. But in the short time I've known him, I knew of his work for a long time before that. And in the short time I came to know him, I thought it would be amazing if he could invite him to campus. And he shared that he was coming for the ISC meeting in Chicago. So it was just a perfect alignment of the timing and his presence here. Halvard is research director and research professor at the Peace Research Institute in Oslo. Really amazingly well-known, well-published, well-regarded scholar of climate, of violence, of climate, of state stability, social stability, and it's really a great pleasure to welcome you to campus, Halvard. He is professor of political science at the Norwegian University of Science and Technology, and also serves in an editorial role at the Journal of Peace, Journal of Peace Research. His research is especially known for its focus on the political dimensions of climate change and how climate change is affecting both likelihoods of conflict or not affecting conflict. And his work has been funded by a whole swath of different international organizations, including from the European Union, the World Bank, and the Research Council of Norway. He is the recipient of the Carl Deutsch Award in 1915. His work has been recognized for many other contributions. And today's talk is work that he's doing right now, and I'm really excited to hear what you have to share with us, Halvard. Thank you very much for coming.
Thank you so much, Sharon, first for inviting me and for that very generous introduction. Good morning, or I guess it's good afternoon. Great to see you all, and whomever might be online. It's great to be here and to talk about some of my ongoing research. I guess it's, yeah.
I turned this off, so do you want to hold it?
I mean, I've got my cursor. Yeah. Like Arun alluded to, I will talk about some of my ongoing research, but I will start by providing a little bit of context for that research by saying a few more words about the broader research agenda I'm working on at the moment. I guess I've studied connections between climate and conflict, and especially the extent to which and how climate hazards might influence conflict dynamics for a good while now. I'm increasingly now switching the link and looking more into how conflict affects society's ability to cope with or not be able to cope with climate hazards. So more on conflict as a potential driver of vulnerability to ongoing and potential future climate change impacts. And what I'm going to talk about today also is reflective of that change in the focus of at least my research. So the research agenda that I'm working on more broadly now, and I'm leading some projects on this, really seeks in the aggregate to try to improve on so-called climate change impact assessments. So there's a broad literature, broad and interdisciplinary field of study trying to investigate and quantify different types of cost, monetary, non-monetary costs of climate change across societies. And I think there are ways in which those studies can be further improved. I don't know to what extent you're familiar with these scenarios that are being used in the climate change impact community, but these are scenarios, the so-called SSP, RSP scenarios, are widely also referred to by the IPCC, the Intergovernmental Panel on Climate Change. And they combine two sets of scenarios, basically. The SSPs, the shared socioeconomic pathways, represent alternative trajectories of future societal development. So that the SSPs represent the societies. And then you have these so-called RCPs, the representative concentration pathways, which represent alternative trajectories of future global warming. So when you combine the two into this SSP-RCP matrix, you can play around with different futures in terms of both global warming and societal change. These scenarios have existed for more than a decade now. They are widely used. and have made a lot of progress or made a lot of impact on our understanding about current and especially future risks related to climate change, and also how future societal change might moderate in various ways those risks. Despite the progress that have been achieved through the introduction of this SSP-RCP scenario framework, there are also some limits to these scenarios. And in particular, I would like to highlight one particular limit that applies to the quantification of the SSPs, and that is that they do not really account for future risks to stable growth. So here's a figure that shows a so-called spaghetti plot. Each of those lines represent a country, and these are the least developed states, the least developed countries, and they are graphed in terms of their GDP per capita per year, going from 1970 until the end of this century. This is a figure that shows the least optimistic or the most pessimistic, if you like, scenario, the SSP3 scenario. What is interesting to note here is that historical growth for these least developed countries have been really uneven, and for many countries, you would see that over the last 4 decades, there hasn't been much overall growth, right? But suddenly, and this, I remind you, is the least optimistic scenario, suddenly they really catch up. And their average growth rate going forward is considerably higher than the projected average growth rate for more developed economies. And the reason for that, we argue, is that these economic growth models, they do not really account for potential risks to disruptions in the economy, and those risks typically, not exclusively, but typically come from political instability, including armed conflict. So what my larger project seeks to do are 3 things broadly. First, we want to explore how political context and by implication then some of these potential drivers of disruption might influence climate change impacts in the observed period or the historical record. Second, we want to develop extensions to these existing scenarios that will incorporate political factors that could account for these disruption risks. And then thirdly, to assess the implications of accounting for political development in these impact assessments. What I'm going to talk about today is a paper that looks at that first step about how political factors might moderate climate change related risks. All right, so that was kind of the context for today's talk. Here is an image taken a year and a half ago from the city of Derna in Libya. Nobody, probably you or I, at least I had not heard of the city of Derna until September of 2023, when a flash flood suddenly went through the city and destroyed it completely, and contributed to the loss of lives in the range between 5,000 or 6,000 up to more than 20,000 individuals. I looked for more official or established estimates this morning, and it seems that there still is no agreed upon official estimate, but it's somewhere in the range between 6,000 and 24,000 persons killed because of the flooding. The flooding came as a consequence, or the flash flood came as a consequence of unprecedented rainfall that landed across Libya, but also the greater Mediterranean region in the during the first week of September. So this was clearly an extreme climate-related event. Okay, even so, we didn't see destruction like this everywhere, right? And in the immediate aftermath of this particular disaster, stories started emerging and documents started emerging that showed a lot of concern about the maintenance or lack of maintenance for the dams above the city of Derna that burst because of the heavy rainfall, and how that could have been avoided with better governance, basically, and with a well-functioning political system and with the absence of war. And so this is an extreme case, but I think it highlights how plausibly the political context would affect not only the severity of a disaster, but also the likelihood of a disaster occurring to begin with. Right. So the approach that we take in this paper is a fairly established one. We are using the same risk framework as the IPCC, for example, where risk or impacts are seen as the product of hazards, exposure, and vulnerability. And we are particularly interested in the vulnerability aspect of this study. And there's been a fair amount of research on how socioeconomic conditions in particular are important in shaping local vulnerability to climate hazards. There's been some, but much less focus on various political factors, from the quality of institutions to the presence of peace or the absence of peace. And that's really where our paper hopes to make a contribution. So we really want to focus on political aspects of vulnerability and how that might moderate impacts, focusing on floods as one particular and particularly severe also type of weather-related disaster. By the way, if there's anything unclear, of course, feel free to raise your hands, but otherwise, there should be ample time towards the end to take your questions and have a conversation. So, how do we imagine political development influencing disaster outcomes? I should say, though, that this particular study that I'm presenting now is not really a theory developing paper. It is relatively thin on theory, but using intuition and drawing on some other research at least, we can think of three elements of political development that we believe would be relevant in moderating disaster-related risk. The first relates to the inclusiveness and openness of political institutions, what we often think of as democracy. There is some early research showing that democratic institutions, all else equal, are better able to prepare for and respond to extreme weather events. Secondly, we also believe that the capacity of those institutions, regardless of their open or closed nature, would also matter to the extent that more highly capable institutions are also better able to implement policies and achieve the targets that they set. And lastly, peace, or the breakdown of peace, we expect to reduce the coping capacity of exposed societies. If you think these three dimensions make sense, that is because, or that one reason why they might make sense is because these are really the three elements of the SDGs. So that's basically what we're doing in this paper, is to explore the relevance of SDG 16 for disaster risk. Again, as I mentioned, we're not really developing novel theory here, but we can think of two maybe ways in which these dimensions influence disaster risk. One would be through shaping incentives for protecting and responding, protecting assets, but certainly in particular protecting the population and responding to the population's needs after disaster. And democracy in particular should be good at that. And then also the ability to protect and respond in terms of having access to all the areas that are vulnerable, but also having the capability to invest in more robust infrastructure, early warning systems, evacuation capacity, for example. This is a quantitative global study. We are using the Global Flood Database as our source for the historical record of flood events. We have more than 2,200 flood events since the year 2000, spread around the world. This map shows the centroid of each of those events. The events or the data are georeferenced from satellite data. So basically, we know with fairly high resolution exactly where that flooding occurred, and then we can overlay that with spatial data on human settlements, for example, to also arrive at relatively accurate estimates of the exposure of human population to each of those events. So the unit of analysis is the flood country event. So some floods span across borders. Since our main predictors and the variables we're interested in are country specific, we then split these flood events that cross borders into specific flood country events. So we have then 2,200 and some events. The outcome variable that we're trying to explain here or to predict is reported number of fatalities in each of those flood events. Using Bayesian negative binomial regression with both in-sample and out-sample prediction as our means of assessing importance. And some additional details. I mentioned the 3 dimensions of political development that we're investigating. For each of the 3 dimensions, we are using 2 predictors. For democracy, we're using both voice and accountability from the Worldwide Governance Indicator and inclusion of social groups from VDEM. Institutional quality, likewise represented by 2 factors, government effectiveness and rule of law. All of those 4 indicators are measured at a country level. And then lastly, for conflict, we are focusing partly on the local level. We are measuring the number of battle-related deaths in the flooded area, plus a buffer of 50 kilometers within the last 12 months before the flooding occurred, as a measure of local vulnerability or local conflict exposure. And then we also include a decay function of battle-related deaths in the country over the last 10 years. So basically exposure at the country level to severe armed conflict in recent history. Ideally, we would have wanted to have also local information on quality of governance, for example, but such data are not available in a time-varying format at a global scale. So for the time being, we are limited to country-level indicators for the institutional aspects, but for conflict, at least we are able to look a little bit more at the local level. We have some baseline indicators that are included in all models, including the severity of each flood event in terms of hydrological aspects, measuring basically flood volume or water volume, duration of flood in days. We also account for whether the flooding was associated with a tropical storm, because then typically there will also be greater damages outside of the flooded areas, which could contribute to higher levels of casualties. Individuals killed not because of the flooding itself, but because of the storm that affected a larger area. We also account for the extent to which countries have been exposed to flooding over longer time periods, and we can see reasons both why that would be associated with an increase in fatalities if it reflects, the kind of saturation or overwhelming of society capacity, but it could also reduce potentially current fatalities if there is some element of learning involved. And then importantly, we account for the number of, or the estimated, I should say, number of individuals exposed to flooding in each of those events. We also have some socioeconomic controls in some of the models, including GDP per capita at the country level, and then also human development index measured in the flooded area, like the conflict indicator. Just to show you some results from these models. These are conditional effect plots for the predictions, and the dark line in the middle of each of those represents. Very cool. The dark line in the middle of each of the 6 plots represent the median prediction. And the lines, at least for the 4 institutional indicators, seem to be fairly flat, right? So there doesn't seem to be a super strong association for the median prediction between, for example, accountability and predicted flood mortality, or inclusion and predicted flood mortality. Even so, for inclusion, for example, if you go from the lowest value, close to 0, to the highest observed value, close to 1, there is a roughly reduction in predicted mortality at about 30%. At the median. If you focus on the upper distribution of these prediction intervals, we can think of that more as a worst case scenario. We see that actually whether you have an inclusive or exclusive society matters more in terms of what is the predicted outcome measured in flood mortality. Comparing the different models here and the different indicators, we easily see that the conflict indicators seem to be more influential in shaping predicted mortality from flooding than the others. I should also mention 2 things. First, so these are the shaded areas are prediction intervals. They're not the same and should not be interpreted like confidence intervals. So the fact that they overlap across the scale of the values for the predictor does not mean that they are statistically insignificant. That's one thing. And the other thing is that these different conditional effect plots are estimated in different models. So only one of these indicators is included in each of the models because they correlate considerably. They're also partly capturing the same effect, right? To better compare the different models, we here use two other metrics for assessing overall model performance. Expected log predictive density, ELPD, and stacking. These are two different ways of trying to compare the predictive performance of different models. And here again, we see that the conflict predictors clearly, or the models that include the conflict predictors, clearly perform better. So the predictions from those models are closer to the reported number of casualties. For the stacking, for example, you will see that in sample, the darker orange, the local conflict indicator actually is the best model for close to 70% of all flood events. It's better than all of the other models. So across all of these different methods, across the different samples, we do find that conflict indicators are particularly important in shaping the predicted mortality, but the other political, or at least some of the other political predictors also matter. What does this mean in a real world sense? To try to give you an idea of that, we also made a kind of factual analysis. So first we estimated the model on the in-sample 2000 to 2015 period or 2014 period, and then we predicted the expected number of mortality from flooding for the out-of-sample 2015 to 2018 period. And the red distribution that you see is the distribution of predicted mortality across the flood events in the out-of-sample period. And then we replace the observed values for the political indicators with the values representing New Zealand in 2015, and we re-estimate all of these predictions. So everything else is similar between these two different worlds, except that in the second world, in the blue world, all countries have political characteristics identical to New Zealand. And you see that the distribution of flood deaths is much closer to zero overall. So clearly that matters for the predicted number of deaths from flood events. And across all of these models and across all flood events in this out-of-sample prediction, we find that the average flood is predicted to have 55% lower deaths if that country would have a political characteristics of New Zealand compared to whatever characteristics it would have. So that suggests that there is, in fact, a meaningful role to play for improving political characteristics of countries. So to conclude, we do find evidence that political factors matter for reducing climate-driven risk, or in this particular case, flood-related risk. This is not, I think, a super surprising result, but nonetheless, I think it is important to provide additional evidence that this seems to be the case. We find also that conflict seems to be the most, or armed conflict, I should specify, it seems to be the most influential factor in driving up mortality, and by implication, going from conflict to peace would then be an important way of trying to reduce mortality from flooding events. And this also indicates that the potential for SDG 16, where we haven't seen much progress over the last 10 years, to actually also contribute not only to building peace in societies, but also actually reducing vulnerability to extreme weather events. These findings, we believe, are important also because the tests we are conducting here, we have reason to believe, are actually quite hard to find evidence. One is that there are qualitative differences between the in-sample, where we are training our model, and the out-of-sample, where we are testing our model, in terms of characteristics of flooding, for example. We are also including continent-level random effects here. So each continent is allowed to have a different baseline flood mortality risk, for example. And some of the differences in continent-level latent risk could also be related to average differences across continents in political characteristics. So some of the effect of political institutions could in fact be captured by this random effect specification. And more importantly, also thinking back to the case of Derna, where the main story is not that if Libya had been perfect democracy, they would have been able to reduce the number of casualties, but plausibly they would have been able to avoid that particular disaster. The fact that political factors also plausibly reduce the risk of experiencing severe flooding to begin with, also we believe is one reason why our results are actually relatively conservative. We do see need for better data on many things, and some of the things I would like to highlight are just better information at global scale in terms of society's disaster risk reduction capabilities, early warning systems, evacuation capacity, and also how they have responded to each of these events. If we have been able to better account for that at the local level, we believe that our models also will perform better in terms of providing more accurate fatality predictions. That concludes my brief talk. I would like to also just give a shout out to my colleagues on this particular paper, Paolo Vesco, Jonas Vestby, and Nina Fornusco, who are part of this larger project I talked about in the beginning. All right.
I guess the million-dollar question, particularly with the case used as a motivator, is that the flood risk is non-stationary. And so when we run these models, in this case on data, I think that got up to 2018 was the most recent data. A lot of the challenges, the phenomena we're watching now are not characterized by historical precedents for floodplains. So what are your thoughts a little bit about the role that non-stationary could be playing, non-stationarity might be playing in the flood hazard particularly, and then the liability or at least effect it might have on our model?
Right. No, that's an excellent question. I mean, ideally, we would have wanted to have a much longer time series to begin with, where we also could be able to trace and potentially try to capture some of these non-stationarities. I did mention qualitative differences between the in-sample and out-of-sample period. What is interesting is actually that in the 2000 to 2014 period, the average flood event was more severe in hydrological means, but also in terms of fatality outcomes than for the testing period. So, and especially in terms of fatality, we do see that flood severity has gone down for some reasons, which could be either random or it could be related to, it could be random. I'll mention one more thing. It could be random. We also see that there is a slight shift in the hydrological characteristics of these floods between the test sample and the training sample. How will that influence our ability to predict flood outcomes in the next 5 to 10 years, or let's say multiple decades? It's hard to say, but because both climate and societies will change, right? Which is why I think these scenarios actually, especially if we're thinking more into the long-term future, plays a role. There is one more thing that I did not mention that I remember now that I'm thinking and talking at the same time. I did not mention during my talk that I should have mentioned. And that is that you saw that map of the world with these centroids, right? With 2,225 flood events.
Yeah.
That's the kind of the reported event of floods across the world that satisfy certain inclusion criteria and which have been georeferenced by satellite imagery. Now, there are a number of additional flood events that have occurred in this period that have not been included in our data because of lack of ability for the satellites to actually detect flooded terrain on the ground because of cloud cover, for example. And that is also something that could change, with climate change, different cloud cover could be related to floods, for example. So that's an additional concern, thinking more into the long term. I don't know if this is helpful response.
But no, it's helpful. I mean, for those of us that create these hazard maps, the non-stationarity is actually the big dilemma that we face, being able to reliably quantify the risk and propagate that uncertainty in our models. So I wanted to touch on that first. The second question I had is, terrain was used as one of the variables to at least look at the interaction between the hydrologic process and the land mass. Right. But I was curious why land use, land cover, which is also easily quantified in satellite imagery, was not also factored in.
That's a good question, actually. And you're right, we didn't do that. Not except for, accounting for settlements, but we did not look into all the characteristics related to land use. Unrelated to terrain.
I just think that the deforestation phenomenon in a lot of places I work, the steep topography is dramatically affected by tree cover. Yeah. And then overdevelopment and heavy, concretization of the surface leads to a lot of, in that particular case you used, that was one of the events we studied. there was a lot of conversation about the floodplain management and the decisions there that land use, land cover might have captured actually.
Right, yeah.
Yeah.
Yeah, and I immediately come to think of the island of Hispaniola, of course. Also.
That's I work a lot in Haiti, so yeah.
Exactly.
Yeah.
And the deforestation on one side of the border. No, that's actually an excellent comment. I'll see what we can manage.
Yeah, that actually might be interesting to pull into it. I think it'll give richness, because I 100% concur with what you're saying about local, and the fact that local data is not available in local political process is the big gap. I agree with you.
Yeah.
Because floodplain management is inherently local, and that would be, of course, the magic data to have.
Yeah.
But even land use, land cover could give you a little bit of proxy for how patchy development and land use is, which is a reflection of land use management locally.
Right. Thanks a lot. That's a great comment. Great suggestion. Yeah.
Yeah, this may be sort of a question or comment for like down the line when there's more theory development, because I think I understand like the objective of the paper, like just sort of like showing that the conflict indicators are an important driver of this ultimately, so that they can be included in the larger models. But I think one of my questions would be like, you have thought about the mechanism, right? Like as to ultimately how do these conflict indicators or conflict events translate into higher flood deaths? And I think one of my questions would be whether this may also depend on the type of conflicts that we're seeing, right? Because there's a difference between, say, symmetrical, asymmetrical warfare, and then you may have conflict specifically where there's some degree of state breakdown, which ultimately leads to these situations. Of course, any conflict will be disruptive, but I do think there may be some qualitative differences.
Another great comment. So when we account for conflict, you're right, we don't really separate between different types of conflict. What we are accounting for are predominantly what we call state-based conflicts. So what we measure are basically, the severity in terms of lives lost to fighting, and we think that's a crude but not unreasonable proxy for all sorts of negative externalities from violence, anything from, destruction of infrastructure, disruption of public services, forced displacement. But you're right, in this particular study, we are unable to test some of these plausible mechanisms connecting, conflict severity to increased vulnerability. In a separate paper, we are trying to look more into flood-related displacements and the extent to which that in turn have negative outcomes from extreme weather events. Conflict-related displacements, and whether that in turn have implications for extreme weather events further down the line. But we'll see what comes out of that. But you're right that in this particular more aggregate study, we are unable to test that, but it is something we definitely would want to look more into in the future. Yes.
Thank you. This is really fascinating work. And I just had a couple of questions. One was so as I understand it, you're looking at the country case, right? But you're also, you're able to look subnationally at kind of where this concentrates, because you're looking at events. Is that correct? Yeah. So I was curious, the first question is whether you're finding any of these results in terms of the intensity of loss of life clustering, for instance, if there's several countries but next to each other, they're all experiencing armed conflict, like parts of Central Africa or around the Sahel or whatever it happens to be. Are you finding similarities there, or where there is conflict, or does variation in state capacity, et cetera, explain some of the other variations? So that's just kind of a question about clustering beyond national boundary. The other question, you mentioned that you distinguish between floods that involve storms and those that don't involve storms. I wonder if you could say more about that and whether there's any particular findings out of that. In other words, are the storm-related floods worse? I think of hurricanes or something, but.
On the first question, I'm not sure if I'm able to give you a very clear response on whether we do see particular clustering in our data over and beyond what can be explained by country-specific factors, because some of these predictors obviously also cluster in space, right? And the same we see in the severity of some floodings. But the extent to which we see residual clustering after accounting for these predictors is something I don't think we're looked into. So that's something that would be cool to look into. Sorry, I
The storm.
The storm, yeah.
Yes,
okay. The interesting thing is that the predictive performance of that crude tropical storm dummy variable is really poor. It does not help much in terms of improving predictive capacity. So this was one of those predicted we wanted to include because we expected it to matter, and because we have seen reports of specific flood events and the impact of those flood events, where the reported number of fatalities clearly were counted, or that included people not only affected by the flooding, but also affected, across a much broader region because of the tropical cyclone that went through, a much larger area. So that was something we expected would be important to account for, but which, at least according to our data, does not seem to be a particularly important predictor. Maybe there are more nuanced way of trying to account for storm-related floods than what we have tested, but at least in our somewhat basic, somewhat basic approach, we did not find our signal from that storm dummy, and certainly not as much as we would have expected.
I wonder if that's an artifact of just those types of episodes getting more attention in the news.
And they're also very localized. Tropical storms only happen in very discrete bands on the planet.
Okay.
So it's a proxy that only works in certain areas.
Oh, right.
Right, because it's tropical storms, right? It's not.
We have everything on tropical storms, not all storms. You're right.
Yeah.
I don't know if some of that also is picked up by the continental dummy again, given what you say also about the regional distribution of some of these events. But yeah, no, to me, at least that has been some of the surprising stuff actually, that this didn't give us much in terms of improving our predictive capacity.
So my family in Florida is okay.
No, we'll talk about that later.
Okay.
The political institutions for that.
Well, yeah. Thank you so much.
Yeah.
This Halvard, this is a great talk. Thank you very much. I have a couple of questions about the predictors we're using. Some of it seems to be linked to the way AR6 defines impact in terms of vulnerability, sensitivity, exposure, and hazard. Right? And I wonder, so this is AR6, but the previous assessments talked about vulnerability as being a function of exposure, sensitivity, and adaptive capacity. And I wonder if you were to redo the analysis using the previous definition of vulnerability, how it might change if you have thought about redoing it. The second question I have is about how you define hazard. So you said you use the centroid for the flood events. And is that because information from remote sense data is not really available for the extent or the size of the flood event? Because that you could have a relatively large flood with relatively low mortality and a smaller flood with much higher mortality depending on other features of the event. And so I wonder if you've thought about, if you have data to test, to distinguish between the nature of the hazard based on factors other than mortality, and how that might affect your findings.
To take the last question first, and I understand it wasn't clear from my presentation. We do in fact look into the entire flooded area according to the satellite images.
Okay.
So the world map only showed the centroids, because for most flood events you wouldn't even been able to detect the flooded area anyway.
So you have the data on flooded area.
So we have that. I mean, that is how we estimate number of individuals exposed to flooding, which calculated by overlaying this with settlement, high resolution settlement layers. So we try to account for that, and then our outcome variable is then the recorded number of people killed, controlling for the exposure and our predictors. We have tried to look into also other types of severity beyond human casualties in a separate paper actually that was published in PNAS last year. We looked at flood-related displacements, having a somewhat similar analytical approach, and where we find also, maybe not so surprising, somewhat similar results in terms of these political predictors influencing also flood-related displacement. So we try to, at least to the extent possible, try to account for the local level. For your first question, I don't know. I mean, I'm almost tempted to return the question to you in terms of how you would expect that to matter. Adaptive capacity, for example, if we were to separate that from vulnerability, I think we would very easily end up in a problem with quantifying that and measuring that, right? What would be a good measure at the local level for adaptive capacity, separate from what we think of as vulnerability. But I'd be very keen to have that conversation with you if you have good thoughts on that. But you're right, we take this AR6 approach to understanding risk, where hazard basically is the flooded area, exposure of a number of people there, and then vulnerability are all these political and socioeconomic factors. So,
Yeah. Yeah, I mean, I think in the previous definition, although conceptually these three dimensions of vulnerability were very clear, adaptive capacity, sensitivity, exposure. I think in operationalizing them, one always ran into the problem that sensitivity and adaptive capacity were highly correlated. So that was one issue.
Yeah.
I think vulnerability. Yeah, well, I actually would be very interested in understanding why AR6 changed the definition, because the issue of operationalizing these different dimensions doesn't go away by talking about exposure and hazard and vulnerability. You still have the same question of how do you define hazard, how do you define vulnerability, and how do you define exposure in these two different dimensions.
Yeah.
The standard way for prior to AR6 was to look at climate model predictions and use those. The divergence in the climate model predictions for given areas as a measure of exposure.
Exactly.
But this is not the way most analyses of exposure operationalized it. Mostly they took historical data on event intensity and used that as a proxy for exposure. But we certainly have the climate model data to incorporate into the analysis. But I wonder if the previous definition of exposure is the same in AR6, so if it has changed, and how vulnerability is defined, if it is independent of adaptive capacity and sensitivity in AR6.
So exposure in AR6 is defined as number of individuals who are at risk of being harmed, right, by a hazard.
Okay.
And vulnerability basically is the extent to which, what is the exact wording? Yeah, it slips my mind, but yeah, we can look into that. There is actually in some of the AR6 chapters, and I think this has been an interesting revision of this three-blade propeller, is also to focus on response as the fourth dimension of risk, right? And that's also, thinking back to what kind of data we would love to have would be exactly how are these disasters when they occur immediately responded to by central state authorities, but also international agencies providing relief there, because that could also make a difference in terms of health and mortality outcomes from these events. Yeah. Did I see another? Everybody's happy.
When I think about political context, I think about the relationship between decision makers and the public. And so I think with some of that, I'm wondering how much that gets very complex and complicated. So I'm wondering how much of that is you're able to capture through the analysis that you're doing. It's very similar to the questions about land use and institutions and context, but it's a bit more broad in terms of thinking about how people are responding to or are acceptable with the policy changes, status quo bias, things like that.
Yeah, no, another great comment. It would have been nice to also account for, trust, for example, trust in political institutions, likelihood of compliance if they are, instructed to evacuate ahead of an event, because that can also vary widely across contexts, the extent to which they actually follow advices or they trust the advice that is being given or the warning. I'm sure it is to some extent correlated with some of these variables, but not necessarily very strongly. If you have suggestions for, global time series data to better account for that, I would be all ears. Because I wouldn't be, I don't think I would claim that we are capturing it especially well. We are trying to capture it a little bit, but is that what you think?
Yeah.
Yes.
Yeah.
I was just gonna, sorry, I thought you were gonna finish. I was just gonna say, it's a related question in terms of but why, when you chose the two VDEM indicators that you chose, why did you choose those specific two VDEM indicators, and was it sort of like a theoretically informed decision? And data availability sort of like decision as well, or like that would be my question, because when I think of VDEM, I mean, you could have also taken, I suppose, like the entire index of electoral liberal democracy, another type of combination. So why those two?
So in the appendix to this study, we use the Liberal Democracy Index as, the catch-all indicator of political institutions, and it performs, almost exactly the same as each of the four variables on the left. And these also obviously correlate quite a bit, which is also partly why they are both performing so similarly and, partly capturing the same underlying phenomenon. So how did we land on these particular four dimensions? Partly informed by theory in terms of thinking about orthogonal or at least somewhat different dimensions of political systems, but also by looking into correlation between these indicators and trying to identify some that do not overlap, at least fully, right? So we none of the four political variables here correlate. Well, I shouldn't say a number actually because I don't recall, but they are supposed to not be as highly correlated as some of the other that we have tested and have considered. But then, as I mentioned, the more aggregate index performs, pretty much the same. So it doesn't give us a whole lot actually to set up this, more detailed specification because, democracy seems to capture both the quality of institutions or their capacity to put it that way, but also their inclusive nature. So, but even so, conflict is more important.
I was curious if the state resilience index was one that you looked at, in particular the social cohesion pillar, because it has these trust measures and things, and so those get to some of that more localized.
What's the source of that?
Fund for Peace. So state fragility index is, now they have the state resilience index, which
Right.
measures the social cohesion pillar is one that we've been working on with them because they're interested in shifting. We've had these conversations about the framing around fragility toward more of an asset framing around resilience. And they have this social cohesion pillar that has a number, and like you're saying, you need a good time series. So they pull from fairly recognized sources that are repeatedly reported over time and have good coverage. That's why I got to look back. I was just trying to pull it up and my iPad, I couldn't see it quickly. It's a new index, but the elements that they pull in pre-existed. So even though they've just been reporting it, you could go and reconstruct the pillar yourself, pulling from the sources they're pulling into it. So I'm curious if that could be a good one.
Yeah, I'm not familiar with that. But
yeah, so Fund for Peace, if you go to the website, they have that index up.
Yeah, and that would not be affected by, severe flood outcomes in the past, right?
Yeah.
Because that would be key that, there shouldn't be any endogeneity in the code.
Yeah, it's curious. They went and did it because of COVID. They said it was the moment when there was a global shock, and so you can measure resilience from a baseline in an interesting way before and after COVID. It's one of the few times the whole planet was shocked at the same time, so you can look at how resilience dipped. Yeah. And that's when they started playing with it. Kind of curious.
Yeah, as long as it's reasonably exogenous to these products.
It's a fun one to play with.
Yeah.
Can I ask I'm sorry, go ahead.
No, go ahead.
Just, this is fascinating. The project's absolutely fascinating. I was curious, just from your perspective, what your intuitions or thoughts would be. When I look at these 6 figures, I was curious, when you approach this, were you thinking, okay, well, democracy or institutional quality, accountability, inclusion, et cetera, are we going to see some variation that's driven by the quality of accountability or government effectiveness? And you were surprised not to see that? Because the armed conflict, the conflict history and local conflict, that seems to make sense to me. Mm-hmm. What are your thoughts going into this? Did you expect to see something a little different on these four figures?
Maybe my a priori expectation would be two things. One, I would expect to see a little bit more difference in behavior across these different dimensions. Given that they do not correlate perfectly, I also wouldn't expect all of them to capture all of the same underlying processes, and therefore I would expect their, the shape of the conditional effects to be somewhat different, but they are pretty much similar. That would be one thing, and maybe I would intuitively expect somewhat stronger median predictive effect. But these are not zero. I mean, they are not trivial, even if they are not. And in fact, maybe I can show that. I think I added a slide after here. So here we have compared them to the baseline predictors in terms of exposure, duration, flood severity, but also the socioeconomic indicators. And you can see even for a GDP per capita, which is a ubiquitous catch-all indicator for societal vulnerability, it's not that strong an effect. So, it's actually not that different from some of these institutional factors. Local HDI captures more, but it's not also so surprising since it's more nuanced capturing the situation where the flooding actually occurs. But even local HDI, just by eyeballing at least, has almost more effect than local conflict.
Thank you.
That's interesting.
Yeah.
Sorry, I apologize, I came in late, but very interesting data, so thanks very much for presenting this. I'm kind of wondering if, number one, when you talk about conflict, you're talking about state-sponsored violence, this is that, right?
Yeah, armed conflict against the central government. Yeah.
Okay. So I guess maybe building off that last question, how much are you able to detect the presence of maybe local coping capacities increasing in instances, especially when government accountability and government effectiveness are not there? What's compensating for that? And could that then be speaking then to at least the reduction in flood mortality rates, as opposed to maybe when you're talking about space-based violence where there's actual violence, where you could be then compromising the ability for these local coping mechanisms then to take it.
Right. So the very simple response would be that we do not particularly well capture local coping capacity and the variation in that. We only have a very limited number of predictors that measure things at the ground where the flooding occurred. We have the local HDI. Now I can try to see if this works again. This one, and then we have local conflict. And over and beyond that, and of course the flood specific information, but over and beyond that, GDP per capita and these other institutional factors, they are all measured at country level. And they may correlate somewhat with the average condition in the local level. It probably matters the quality of local institutions, whether you are in a high capacity or low capacity society, but we are not particularly well able to capture that due to lack of data at global scale.
So I'm very interested to see what I think may be a pattern in these plots, that where you have information about the locality, the effects seem to have more of a slope to them. And where the information is more at the national level, it seems the local effects seem to get drowned out by the measure at the national level.
Yeah.
So with that in mind, I wonder if there is data on political participation in terms of most recent elections and how many people voted compared to the total number of people. Or if there's information from the World Value Survey that you can sort of target to the locality, or information from census data that you can take out for estimating additional sort of locally specific measures of levels of development, for example. So I wonder if those are things you have thought about or tried, or that's just not possible, or too much complicated for the extraction process, or
No, it is very clear from these plots that local information improves the ability of the model to predict accurately, right? So both the plot-specific information, but also local HDI, local conflict adds more to our ability to predict correctly than these cruder. So there's a lot of noise going on at the country level predictors. We have thought about, we haven't formally tested many of the like value surveys or other types of survey-based data. To the extent that they are, well, I'm not so sure actually to what extent they would be representative at the local level across all of those countries.
So the census data would be just census data. So it's not about representation.
The census data, exactly.
Yeah.
But I'm thinking more in terms of survey data.
I think some of the DHS data sets, especially the more recent ones, are representative at the second jurisdictional level, not the third jurisdictional level. So it would still be somewhat noisy, but less noisy than national jurisdiction.
Yeah.
I don't know about the World Value Survey. I've never used those data sets.
No, but I mean, it's a good thought. I guess we would end up in a situation where we would have a trade-off between, adding more local information and perhaps better quality data, but losing then some observations, and probably non-random loss of flood events, right? From societies and from locations where we simply do not have that kind of information at that level of detail. But maybe it's something we should reconsider before publishing this. I'll have a conversation.
Yeah, we can talk about it.
Yeah, just very briefly to that, and again, it can be also before or after publishing, but the ECI, the Environmental Change Initiative here in Notre Dame, like they one of the reasons they developed is like global, it's kind of GOCA, like I think global urban.
Oh, GUCA, yeah.
Yeah.
The downscaling.
Exactly, like
Yeah.
basically measuring adaptive capacity of cities.
Yeah.
Specific cities, right? Was that, I mean, one of, from surveying the literature, it was like a project we did for the US government for like a couple of months, was we noticed that one of the key sort of variables in measuring adaptive capacity was sort of like either government effectiveness at the local level or a sort of measure of collective action at the local level. But the problem is that there wasn't any data on that or sources that we could tap to then be able to quantify that. So that's, I think, what they tried to do with GUCA. I don't know how far they got into the process, but I know that was a project that was trying to sort of like get at this local level data on adaptive capacity at the very least.
I totally understand those challenges. No, we haven't looked around for other types of information that could provide us some insights into local capacity. But unfortunately, some of the information that we have found also seems to be endogenous to previous flood events in terms of, having had a devastating flood would be an indication of poor coping capacity and low adaptive capacity, and therefore, you are downgraded, right? And we would like to avoid that in order to have as exogenous as possible predicted. Yeah.
That's the truth.
Of course, we do not avoid that completely either, because potentially, these local HDI and local conflict indicators could also be influenced by previous floods in the same area.
Yeah.
So I want to thank everybody for coming to Halvard's talk. Halvard, thank you first of all for taking the time to come down to see us and tell us a little bit about your work. And thank you everybody for coming.
Thanks.